we see some facts that the problem need to be solved by different technology, and not we have a technology to trying to solve some problem. So
Right.
problem come first, and then the problem can be split into several stages, and the different stage is a sub problem of the whole problem they want to solve. And
Right.
the first problem maybe use SQL is better. The second problem, subset problem, maybe use Graph is better. The third one maybe use Spark or some machine learning tool is better.
Yeah. Yeah.
But before that, and thanks to for the data lake, it makes this kind of stuff pretty easy.
Hey, everybody, it's Casey Law, your host for the Data Fabric Show. I am back, and today we're going to mix it up a little bit. I know in the past, previous episodes, we've had data leaders, chief data officers from the companies talk about some of the challenges they have, how they see AI shifting. Today, we're going to mix it up a little bit. Joining me today is actually co-founder and CEO of a very cool data company called PuppyGraph. So Weimo Liu is a co-founder and CEO, and he's going to talk a little bit about this exciting technology of graph databases, talk about PuppyGraph, and talk about his journey. So I'm sure you guys are going to have a good time. So Weimo, please say hello to everyone here.
Hi, everybody. Thank you so much, Casey. It's a great honor for us to join your show. Yeah,
great to have you. Now, first, I got to say that is a very adorable puppy logo you have there. So can you tell us how you guys came about with the name PuppyGraph?
Yeah, there are several reasons. We have a puppy on our team.
Okay.
Yeah,
right.
and also want to have something adorable with what we are doing, like DuckDB, and we are PuppyGraph. Yeah.
There you go.
And the third reason is that PuppyGraph.com only costs us $3.
See, that's the reason. If you're a founder and you're thinking about SEO, look at that. That is a very, very practical reason. $3 acquisition cost for the domain. Okay, that's awesome. Weimo, for a lot of the folks who may not know, maybe you could tell us a little bit about what is a graph database and why is it helpful?
Yeah, since I think the graph database is a popular concept since 15 years ago, and there are a lot of problems. The data is nature to be a graph, like a social network, and transaction between bank accounts, and blockchain, and also cybersecurity, and also like a lot of others, like health industry, and supply chain for manufacturing. So if user can model it as a graph, then sometimes some problem is pretty straightforward. And if you can, of course, you can also use other tools, like you can use a Python tool, you can use SQL, but kind of you compile the graph problem into SQL or Python program, and then write on computer, and computer kind of compile it back to graph problem, and then give you the result. Yeah, but if you have
for a very specific use case that you would use a graph database for, or do you think that we've made so many advancements in the last 15 years that graph databases can also use to replace some traditional SQL-based workloads?
Yeah, this is a big problem since graph database. A lot of graph database community believe that they can replace SQL database, but
I'm going to say no.
Yeah,
that's my opinion, but please tell me otherwise.
Yeah, but based on the reality of last 10 years, I think it's hard. So it's kind of weird since a lot of problem in nature to be a graph. And like the big news, Viz acquired by Google is the big news today. The CEO said that the world is a graph, but not tables. And Viz use cybersecurity as an example to prove that. So it's a very popular blog. But the problem is that the adoption is much lower than most people expected.
Right.
Then
I think the reason why is I think a lot of people, and probably myself included, probably don't know the right or the best use case, right, for a graph database and when we would need it. A lot of times when we think about traditional analytics, we still think tables and rows, right? We still think, your standard aggregations that you need to do and visualize. But I know like a lot of social media companies, like obviously Uber is very famous for using graph database. So, I know using like ML for like fraud detection. So I think there's definitely use cases where if you need to see relationships, across multiple objects, graph database seems to be the way to go. But I think for a lot of folks, they may not know about those type of use cases, and that's why maybe the lack of education, if you will.
Yeah, since actually before I joined Google, I work at a Series C graph database startup. When I joined the interview day, actually, they are celebrating the close of Series A, and they're open champion. Everyone is excited. I got moved as well and withdraw all the other offer and the interview. And
Right.
I worked there for almost 3 years. I see a
Yeah.
lot of customer users engage with us. They have strong interest in graph, and also the use case is perfect for graph, but it's never in production. At that time, I didn't figure out why, and then I joined. But I think there must be something wrong, so I joined Google.
You're saying the customer understands the use case, what graph database should be used for. They get excited, they buy it, they put it in, and you have to be a pretty sophisticated customer to, first of all, pick a graph database, right? So these are not, unsophisticated people. But you're saying even after all that, nothing is in production. That's a very good, very interesting observation. Please tell us a little bit more about that.
Yeah, since at that time I didn't figure out why, and then I joined Google because it's a safe choice, and then I worked at F1 team, the unified SQL query engine inside Google, and then I learned a lot there. Since it's have a bit more than billions query per day, and not only software engineer and data scientists are using it, but also marketing people, the sales people. And then I realized that it's easy to use and see the ROI first is very important to adopt something new. And the F1 is a SQL query engine can query all the data as it is without moving it. You can just be here and then query and then get the result without any prepare work. I think this is amazing and can benefit graph even more, since a big blocker of graph is that people need to do some investment before they see the ROI.
What do you mean by that? Because I've been to your website, right? And I see like power of the graph database without the ETL, and you have a customer saying, "Oh my God, we're able to use the graph database without ETL." What do you mean by that? Because I always normally associate ETL or ELT with kind of SQL-based queries, and if you're not going against traditional SQL-based queries, like tell us why that is significant for our viewers.
For example, a typical graph use case is anti-fraud, and usually the ground truth data is somewhere else. Like user already have tables with transaction between accounts, like column sender, column receiver, and amount, timestamp, and a lot of other attributes. In this case, physically is a table, but logically it's already a graph. And it's easy to imagine that there will be a lot of potential can find insight if it's if it's in graph database. But the problem is that you need first move the entire dataset from database like Oracle, Postgres into a graph database, which means you have two copies of data.
I see. So in order to get the structure of the graph database, you first need to move and load the data into a graph database and transform the format into a graph database first before you can get the visual output of the graph database. Traditionally, that's where you guys come in, right? You guys said, "Hey, we'll give you the benefits of the graph database, but your data can sit where it is." So is can I say your technology is it's kind of like data virtualization, or kind of like Trino for SQL in the SQL world, where you don't have to move the data to be able to query the data? Like, is that like a similar analogy in terms of what you guys are offering?
Yeah, exactly. You exactly got the point. We want us to be the Trino of graph.
Okay.
Yeah,
Very, very cool.
Yeah, so if you already have data somewhere, like in Oracle, in Postgres, in Snowflake, or in Databricks, or the most popular one, Iceberg, in the last year, and we can see that if you already have table, logically you have a graph. You just tell us what graph schema looks like, and then how is mapping from the entity to the tables. Like this table is type of nodes, and that table is a type of edges. And then physically they are still tables, but logically you already have a graph, and you can find inside. For example, the transaction between accounts. For example, if you and I are doing something bad, and
I would never do that. Weimo, come on, man.
yeah, and I'm labeled as a bad guy. People don't know you as a bad guy as well. And we're trying to transfer money. We definitely want to create maybe 100 fake accounts. And
that would be something a bad guy would want to do. Yes, I can see that.
Yeah, and I transfer to 10 fake accounts, and 10 fake accounts transfer another 20 maybe, and then finally all the money go to you, because we don't want to leave the money in fake accounts.
Why? Of course not. By the way, I'm learning a lot about how to illegally transfer money, and that's the unintended consequence of the Data Fabric show. But please go on.
Yeah, and then it's pretty easy for a graph to traverse where the money finally goes.
I see.
But if still in SQL database or data warehouse, it's hard to maintain this. Even someone writes this is almost unreadable. And no one knows what happened.
You'd have to really be the expert and really understand. Whereas this makes it visually, easy for you to kind of see the relationship, the origin, the destination, of what happens each time. It's almost like lineage, right? It's almost like data lineage in a way from that perspective, in kind of the data governance world. And so, so you saw that, hey, there's a gap in this space. You decided, I'm going to start a company, and my graph database is actually going to make it into production. Was that the goal that you had when you started PuppyGraph?
Yes, since we want to bring graph to more people, and then there's a certain case users still need to use graph database. Like if they just hold the ground truth for transactional data, like A transfer money to B, and if I transfer maybe $100 to you, and we need to make sure that my balance reduce and your balance increase at the same time. So definitely only graph database can do it. But for a lot of use case, like if you already use Oracle or Postgres to host the ground truth, but you need to know, where the money goes. And in this case, if user need to make a decision to use graph database first, it will make a very hard decision for user to use graph database.
I see.
So we can let everybody see the ROI of graph before they make heavy investment.
I like it. Cool. Okay, so how long have you guys been around? Tell me a little bit about that.
We incorporate May 1st, 2023.
Oh my gosh.
Yeah, almost 2 years. Yeah.
Okay, good for you. And so I see you guys have an open source version and a commercial version. Is that true? Okay.
Our engine is not open sourced.
Okay.
But we have a bunch of library and open sourced and used by different big companies. Since some big company only want to use the open source product, so in this case, we open source some of the components of us, and they can just adopt it.
Got it. Okay, so you don't have to use the whole product. You can just use some components.
Yeah, we have the UI and some management, and then user can leverage this tool as well. And also for the AI framework, some simple GraphRag AI framework, user can just use it as is. And they don't need to have to connect to PuppyGraph engine. They can, of course, use other graph database. Since we want to contribute to the community.
How dare you actually want to make the community better? Oh my gosh, Weimo, come on. That's awesome. Okay, so I see you guys raised $5 million. Is the goal to keep further developing the product and the community, or you mainly focus on like go to market right now? What's your plan right now?
We are doing both. Like, yes.
Good answer. I'm sure your VC, if she's watching, I'm sure she'll be very happy to hear that.
Yeah. Since we write some technical blog, both by ourselves and with our partners, and we have a lot of partners which is famous in the big data area, like Databricks and Amazon S3, and also Single Store, Red Panda, Stream Native, and Dreamio, MotherDuck, and a lot. Yeah, since we want to bring additional compatibility to their user, and it's how we will have some step by step how to
Right.
plug and play. User don't need to rewrite any of their existing pipeline. It's just add a new thing connected to their existing one, and then have a graph
I see.
capability.
I see. So you want to add that graph capability to some of these existing data platform vendors.
Yeah.
Got it. Okay.
And
So you have like custom like SDKs, or is it all through kind of open API standards or REST APIs that they can, implement?
we're trying to always follow the standard and don't make a user lost in the complex things.
Good man.
Yeah, and because we support the open source query language, graph query language, like Apache Gremlin and also OpenCipher, so the existing ecosystem and application can directly run on our product.
Got it. Got it. Very, very cool. Now there's obviously there's some other graph databases out there, right? Like Neo4j, TigerGraph, which I believe you worked at, et cetera. What's special about PuppyGraph when you compare to it, other than the whole you don't need to move data? Is that the biggest thing, or are there other things about PuppyGraph that kind of makes this the next version or the next evolution of graph databases?
Yeah, since this is an interesting problem, since some of them believe we are competitors, but most of them treated us as their partner.
Okay.
Yeah, since like Google Spanner Graph and Neo4j, and we have a very happy conversation, and we almost finished the integration. May announce the partnership soon. Yeah, since
Good. Good.
what we are doing is that we can query the graph database as an analytic layer. So because we don't have the ability to make things transactional operations, and we don't support ACID, so the graph database user still need to use graph database.
Right.
But we want to make the graph usage broader than before.
I see.
Which means if user already have data somewhere else, sometimes they won't use graph database, but they want graph. And definitely, we have some good friends from Google Spanner Graph and Neo4j. They are happy to collaborate with us.
Right.
Since
With you can actually reach the data that they would have a hard time reaching, and then therefore provide that graph experience to those different data sources for the customers. But then they can fall back on, like the Neo4js of the world, Spanners of the world, to ensure that if ACID is required, right, that transactional consistency is there.
yeah. Since for example, a typical case is that for the transactional data, and it's already in Neo4j, for example, if some fintech company, they can help a customer to transfer money, and they may use the graph database already. And we can help them in that they also have user behavior and some other logs. If we can query all the data as a bigger graph, then it will be much easier for the user to have more insights. If we don't have a partnership, then the problem will be it's a decision that whether load the data from a graph database to data warehouse, SQL data warehouse, or load the SQL data warehouse data to graph database. Both of them are hard. And it's hard to make the insights integrate very well. So yeah, we can help them to, and also for the graph database user, to make the decision easier, since they see that they don't need to make all the data in graph database, and they don't need to make all the data in SQL data warehouse. They can use the correct tool as the correct place, and they don't need to worry about the later stage.
Got it. No, thank you for clarifying that. That's very interesting. So I think one thing that obviously is hot on everyone's mind is AI, right? GenAI, of course, has kind of hit the scenes, hit the ground running hard. Every organization is working hard to adopt GenAI and roll out AI projects. Where do you see PuppyGraph in this story, and graph databases in this story? Like, how can this be a solution to kind of help roll out AI projects faster or easier?
Yeah, since one is that we graph bring more semantic to large language model. Since for LLM, we think that if just the text-to-SQL is kind of self-driving for a car, but if a user already have a graph, it's kind of self-driving of a train. So it's much more easier because for certain data, its relations to other data have been predefined before we send it to LLM. Because, for example, person, if they have a user profile, and what this user do is already predefined in graph. So if you have 100 table, maybe only 6 table is related to user profile table. But if just generated from raw to some SQL, you need to figure out all the 100 table what they are doing. So this makes...
So I think what you're saying is when it comes to like Gen AI, specifically maybe like text-to-SQL, it's very important that you've got a semantic layer integrated, so that way you have that natural language accurately maps right to the specific definition of a term for your organization. And while people, rely on SQL as extensible, and you've got a RAG framework for Gen AI, you're saying that with a graph database, that lookup accuracy and that speed would actually be greatly improved than versus just throwing a RAG framework against the traditional, SQL database. Is that kind of similar to what you expressed?
Yeah, it has certain advantage, but we don't want to say that it's always better than SQL since we don't have...
No. So
we don't have a proof. But
I mean, look, it's like I think the semantic layer piece definitely makes sense, right? It's much easier to express logical and entity relationships through a graph database. So that makes sense to me. I think the thing that I didn't think about was, is there a performance gain, a performance advantage you get? Because like you mentioned your example, you don't have to go look up 600 tables to go find especially, you already know that this entity exists right here, that you can go instantly get that. And I think we've all been kind of used to throwing hardware at the problem, right? Throwing more CPU, more compute, more memory at the problem. And so we probably say, oh, well, as long as I throw it against my Databricks, throw it against, my AWS, and just, here's my RAG framework, it'll eventually get there. But I think everything breaks at scale, right? Or everything gets really expensive at scale. So like, sure, you could at small scale, but at big scale, that could become a very expensive operation. Would that be accurate?
Yes. I think the data lake will be very important, in my opinion, because data lake just you can have everything about your data in there. So the cost is very low, and the performance is actually pretty good based on our experience.
Right.
And you can have your structured data, semi-structured data, documents, and even video and image. And then you can organize everything together. And we're trying to be the middle layer and organize some of your structured and semi-structured data and even documents. And you can have a whole picture of what's this data and what's that data and what's the relation. And we can help make it easier for the user to have understanding, and also have make LLM easier to understand what happened.
Yeah. So this is interesting though, right? If a user asks a question in natural language against the LLM, how would you know to run the query via graph database versus do straight text-to-SQL against the data warehouse? Like how will you kind of figure out how to, pull the right, and use the right SQL execution engine in this case?
Actually, since sometimes the problem is definitely can be answered by a single table. In this case, you can just use SQL and everybody understands it. And
but the user wouldn't know, right? Like when the user does text SQL, he's just asking a question. You wouldn't know. A lot of times the user doesn't even know where the data is, right?
Yeah, this is
how would they know? Like, oh, I should go, look this up with PuppyGraph, or no, just go ahead and do straight text-to-SQL.
Oh, this is an interesting part. Since
we start a new company.
We saw some magic for reinforcement learning, which means you can issue different things to different system, and then you will. Sometimes it's just a success. Sometimes you will have an error message. And one thing we're trying to improve is that we're trying to make the error message super clear, so it's cannot be only understood by our user, but also can understand by LLM. And then LLM can, based on the error message, to send another query. In this case, if a very robust and generic, for example, chatbot talk with your data, it won't be some very simple architecture like you just use graph, just use vector, or just use SQL. You kind of send different requests in different API and then see what's returned. And then you can do some reinforcement learning, and also you can cross-validate what happened. In this case,
but you got to build that into the app, right? Like the developer needs to like kind of build in like this is the type of database I wanted to hit, right? Relational store, vector, or graph. So it's still up to the design of the app at the end of the day to do that. It wouldn't dynamically say based on your question.
Yeah.
I instantly know, unless there's some serious reinforcement training models that you kind of put it through.
Yeah, since a general chatbot with your data is hard. I want to say impossible, but since things change very fast, I'm not sure. But based on our current experience, it's very hard to have a general chatbot. You have to do a lot of prompt engineer and a lot of pre-work.
I think, one of the areas I've seen good graph adoption is, say, like a knowledge graph, like in my world with data fabric, right? Where you want to be able to understand where the data came from, where the data has gone, right? So not just backward lineage, but also downstream impact as well. That's where, I can see like graph database having a great implementation. And so that way it helps, right, the user be more confident in whether or not they should be using this data, boost the confidence score, and then through metadata from that, right, you can use active metadata to then train or just pass the active metadata prompts to the LLM, right? So now the LLM is going to have the strongest signals that it needs to go and make that decision. So I've seen that work very, very well. Are there other instances where you are seeing good adoption, right, of graph technology recently?
Yeah, so another thing we saw is that how we leverage the structured data. Like I'll talk some example like IMDb data is a very popular movie website, and there are already some chatbot can answer your question based on it. And currently, because it's a have web page public, so user can train on or make it into vector database and then help you to do some question answering. So we see that you can just download the structured data very clean from IMDb official website.
Right.
And you can have just the tables and well organized, and all data has been cleaned already. And we can build a logical graph on top of it and then answer some specific question, especially the data-oriented question, like who collaborates with Jackie Chan most, or
I can play 6 degrees of Kevin Bacon.
Yeah,
using PuppyGraph and the IMDb database. Is that what you're telling me? I would be the master at 6 degrees of Kevin Bacon.
Yeah, exactly. And in this case, you can just leverage the existing structured data, which can benefit a lot. And we also see this from the health industry. There are a lot of public data, well structured, and you can download it as tables. And before that, because there are so many tables, and I think it's maybe some legacy problem is that the column name and table name is usually very short, like 2 or 3 letters. Because I think it's because 30 years ago, it's a long column name is occupied out of disk space. So it's hard to understand what's happening in the dataset. You need to read long documents. But now you can leverage modeling that graph and see what happened easily.
Got it. Tell me a little bit about your plans. You got $5 million raised, got plenty of cash now. Tell me about kind of your ICP, like is there a particular vertical, a particular use case, a particular tech stack, or a user that you're going after first, and why? I'd love to kind of understand your business a little bit.
Yeah, we see the attraction and the inbound customer from different industry. And some of them we never expected. Like we just signed a contract with one of the largest air conditioner manufacturer in US.
Congratulations.
And, yeah, and yeah, they have big data, and the use case is supply chain. But I think before that they use SQL to do it.
Right.
But some complex use case they haven't done before. They see the value and they want to try graph. So that's why they're looking out. So their data already in Postgres and Google BigQuery. And then
are you going to put me out of a job because I'm a SQL guy? I'm kidding. I'm kidding. This is good stuff.
The interesting part is that our product increased the SQL usage.
Okay.
Just all the existing SQL pipelines still there.
All right.
The new use case, usually they just give it up. But now they see the possibility. So the people,
maybe they can explore new ideas and they can kind of answer new questions, right? Because you're giving them that visual relationship mapping that they would have not been able to get without PuppyGraph. Okay, and that's kind of cool. Okay, so you mentioned unexpected customer air conditioning, but is there a particular vertical or use case or industry that you guys are focused on?
We see the inbound customer and the users. The two most popular industries cybersecurity and financial institution, because they have some nature graph problem to be solved, like anti-fraud in financial tech, and also cybersecurity, since they are very complicated query. And some of them was written in SQL. Sometimes it's they have some Ruby implementation. They have some other implementation. But when they want to add additional features, it will be hard. So, which means we are not replacing anything, but bring more capability. And then we see why we have a lot of partners from the big data world is because that it also increased the other vendors' usage. For example, a fintech use case, the user actually have a transaction between all the accounts. And when they sometimes do the anti-fraud, they don't want to have a graph run on their raw data. Because, for example, if you and I transfer money for 100 times, then it will be 100 edges between us. But usually, they just need a certain time interval, like 3 in the latest week, or in last week, or in the latest 3 months. And so they first run a group by in SQL. And then the weight of the edge will be the sum of all the transactions between us during that time frame. So it will SQL first, and then graph later. And the result will write back to data lake like Iceberg. That will be used by SQL or Spark again. So we see a lot of new use case, and to increase both streaming, SQL, and also Spark machine learning tools usage. Because
are you saying in those particular usage is the value add for a customer that they get to see what they should be moving and why first before they do that migration to Spark or to Iceberg? Is that one of the reasons why you think you're seeing good adoption in those kind of workloads?
We see some fact that the problem need to be solved by different technology, and not we have a technology to trying to solve some problem.
Right.
So problem come first, and then the problem can be split into several stages, and the different stage is the sub problem of the whole problem they want to solve. And the first problem maybe use SQL is better. The second problem, subset problem, maybe use graph is better. The third one maybe use Spark or some machine learning tool is better.
Yeah.
But before that, and thanks to for the data lake, it makes this kind of stuff pretty easy. But before that, if everyone want to keep the data in their own vendor, because I think 10 years ago, the vendor lock-in is a big factor. The data vendor trying to keep their user, and because they keep the data and then can keep the user. But the problem will be big problem cannot be solved by a single tool. And if you just locked in one vendor, then there will be a lot of ETL between different tools, like
Sure.
load MongoDB to maybe Postgres, or load to Snowflake, and then some of the Snowflake data need to be load into write into Parquet file and then run by Spark, and then it will be very expensive and also time consuming. Sometimes, especially for the big data, the ETL fail a lot, and especially we need to do it every day, even
Pipelines, come on. I don't know what you're talking about. That never happens. Come on.
yeah. So thanks to the data lakehouse architect,
Yeah.
and a bunch of tools can exist together and to solve a complex problem. And
Yeah.
each lab can have their best tool.
I think there's some very, interesting use case. Like, I was just thinking out loud on the fly here, right? So Prometheum as a data fabric, right? We use Trino underneath, right? So obviously there's the federated query aspect, and we have a global metadata index or a global catalog of all the data, different sources. But what we see is metadata. What you guys would be able to see are actual relationships, right? Which I think would be very powerful, right? The metadata that we provide plus the actual relationship mapping to then give insights to a user in terms of what questions that they could ask. Because now they know, oh, these relationships actually exist, these entities actually exist. And by providing that question to Prometheum, the data fabric, can then actually build, right, that data product, aka that data set, that query, visualization, et cetera. And if they need to expand that and see the relationship deeper, right? Something like PuppyGraph can be used to see. So this is actually really good. As we were talking, I started thinking about, hey, like there could be a nice partnership here that we could possibly think about, right? Of the data fabric, right? And working alongside of your PuppyGraph. So this is very cool. Weimo, thank you so much for being a guest. Congratulations on launching the company, getting funded, and your initial traction. I'm really, really excited for you guys. Can't wait to see what you're doing next. And yes, definitely love to keep in touch and see if we can explore partnership.
Yeah, thank you so much for the opportunity, Casey.
Thank you guys for joining us for another exciting episode of the Data Fabric Show. Weimo Liu, co-founder and CEO of PuppyGraph. Thanks, everyone.
Thank you.